Welcome, class, to part 2. This is going to be 10-7, volume of pyramids and cones. So we just did the surface area. Now we're going to add in the volume. So we've already done all the vocabulary words, and now we're just using them in formulas. So I have just a little bit to talk about the formula. Then I have some examples, and then we'll talk some more in class about these. So volume, that's filling up that inside space. So surface area was kind of like the wrapping, and now what are we going to fill these pyramids with? So the volume of a pyramid, we're going to have a big B, and we're going to have an H. So volume equals 1/3 big B times H. And remember, big B is the area of the base, which for pyramids can change shape. And then the H, that's the perpendicular distance from the vertex of the pyramid. Remember we talked vertex? To the base. And it hits the center of that base. And notice you're going to have a right triangle inside there. So all our right triangle properties, Pythagorean theorem, all of those things are going to come in handy when helping us out. Because sometimes we may need to find the slant height from here, and you're going to have this triangle inside of a pyramid. We're also going to talk about the cones today. So if you look on the formula chart, it simply says 1/3 big B times H. And then since every time we have a cone, all of our bases are circles, I can even replace this big B with a pi r squared. So if I wanted to write 1/3 pi r squared times H, or even pi r squared H all over 3. If you just know the formula and you know how to replace your areas in here, then everything should be a-okay. But pi r squared is the area of the base in the case of all cones. All right, so let's jump right in and see if we can solve some problems. And I'm actually going to not start with problem number 1. I'm going to start with problem number 3. Then we're going to talk about number 2. And then we're going to talk about number 1. So a little bit different order, and you'll have number 4 as a kind of a challenge problem. Let's see what you can do with it on your own. All right, so, and again, I am on the left side of the comp book. My 10-5's on the right, and here I just moved to the left. All right, it says find the volume of this composite figure. So we may want to identify what two shapes we have and then fill in any dimensions that I can't really read. So on this side, hopefully you've already recognized this as a cone. And then on this side, I have what appears to be 3 by 3 base, so a square pyramid. So that'll be nice to find the area of that base. So squares are pretty easy to find. All right, so find the volume of the cone. Volume, we said, was 1/3 big B times H. So 1/3 area of this cone base. If you can't tell, it does have a altitude of 4 feet, but we need the radius. And notice the radius, if the whole diameter touches all of this square. So I have a diameter of 3. That gives me a radius of 1.5. And then, of course, we said the height was 4. Okay, and we are going to add, in this case, one's not inside of the other. So I also need the volume of the pyramid. So another 1/3 area of the base. So 3 squared, or 3 times 3. And then the height of this pyramid on this side. And again, it is also 4. That's this little dotted line in here. So I had a base of a circle and a base of a square, and both altitudes happen to be 4. So now I can throw it in my calculator. I will have to do a little rounding, or let's see if I can leave it in exact to begin with. So exactly, I have 3 pi on this side. That's 1.5 squared, which is 2.25, times 4 divided by 3, and I get 3. Plus, this is going to be 9 times 4 divided by 3, which is 12. So here it is an exact answer. And if I want to round it, all I have to do is put it in my calculator, if you can see that there without the glare. Put it in my calculator, hit enter, and then we can decide what's going to be the best rounding options for us. So I'm just going to round it to the tenths, so 21.4. But don't forget my units are feet, and since I'm talking volume, now my units are cubed. So we've talked about that when we did the volumes for the prisms and the cylinders, and now again, volume of pyramids and cones, my units are still cubed. All right, so speaking of cubing my units, I'm going to come up to number 2, and number 2 is asking you to describe the effect on the volume if the volume is multiplied by this. So I'm not going to do a test figure. I want you to start realizing the pattern that's going on and see if you can answer this question. Now, if it asked me for the effect of surface area, remember I just need to identify my scale factor, which in this case is 3/2. And if I wanted surface area, remember all I would have to do is 3/2 squared. But since we're talking volume, think back to what the units on volume is. So I'm going to take my scale factor and I'm going to cube it. And then this translates to 9/8. Whoops, that's a mistake. I apologize. It should be 27/8. 3 cubed is 27. 2 cubed is 8. I apologize for that. All right, so finding those shortcuts. It's going to speed up those problems. All right, last little example, and then you'll have one by yourself that we will be checking in class. So attempt it or you won't get your stamp. And then this one, now I'm finding volume of a composite figure. And notice I have a cone inside of a cube. So the area that you're finding, or the volume that you're finding, is actually kind of what's left over if I could shove this cone inside of this cube. So if you could think of it maybe as something being filled with water, and then I smash a cone inside there, how much water would be left over? And I've actually seen this in engineering before, so I can tell you all about that in class. So we need to find the volume of my cone and the volume of my cube. And then instead of adding, like I did in this case, I'm now going to have to subtract. So cube minus cone. So first things first, finding the volume of a cube, which you did in the last section. So volume, remember, is area of the base times the height. So 4 times 4 times 4, or 4 cubed, minus the volume of a cone. And we just talked about that. Here's the formula right here. So 1/3 pi r in this case, if the diameter is 4, then the r should be 2 squared. And then the height of the cone matches the height of the cube. So 4. So hopefully you're seeing all those things in here, even though they didn't label it for you. So you should be able to label those things for yourself. You're going to see problems like this again. So let's start doing some calculations. 4 cubed is 64. 2 squared is 4. Times 4 is 16. So I have 16/3 pi. There's an exact answer. And now I can go to my calculator. So let's get in our calculator here and do 64 minus 16/3 pi. And I should have 47 point, I'm going to round that to 2 feet. And then remember we're talking volume, so those are feet cubed. So go back, make sure I did all my calculations correctly and don't have any mistakes happening, because they happen. And I will see you all in class. I hope you enjoyed the little videos. Don't forget, you do need to work on number 4. Kind of a little challenge. This time they're asking you for surface area. You're talking about a cone, and they gave you the volume. So you will need to work backwards. They also gave you the height. This is the actual H height, not the slant height. So do a little backwards. Get it solved. I have faith in you that you can do it. I can't wait to see your answers. So have a great evening, and I will see you tomorrow.